All right, so we on statistics, as you guys would know. And what we're trying to do is to get into the graphing aspect of it right now. All right. So three types of graphs we're trying to look at right now is going to be the histograms, the frequency polygons, as well as the cumulative frequency chart. So these are three things that we need to know how to be able to construct and how to interpret and how to do. So I'll let you guys take down the objectives. You guys can hear me good, right? All right, you guys got it? Okay, nice. All right, so the first one we're gonna look at is bar charts, basically that, and histograms. So we want to look at the difference between the two because it's easy to confuse bar graphs with histograms. They are similar, but they are different. So bar graphs are used for comparing different categories of data, whereas histograms are used for comparing continuous data. So the next thing, bar graphs have gaps between each category, whereas histograms do not have gaps. So when we look at this diagram below, as you can see here, we have a bar graph here, and as you can see, we have gaps. So this is what we are used to seeing that we learned from primary school. We have some bars that measure how much something has, but in between the bars we have gaps. Whereas when you look at the histograms now, we see that they're together. The reason why they're together, just like the boundaries we spoke about last time, you remember we spoke about boundaries last class? At the boundaries is where we run off into the next set of numbers or the next set of data. So in this case, as you can see here, these numbers would represent the boundaries for that particular set of data. Okay, so from here to here we have a certain amount, from here to have a certain amount, which matches up to whatever the case is. So how do we construct histograms? The first things we need to identify is the upper and lower class boundaries. Notice what I said, the upper and lower class boundaries, which makes sense because the boundaries is basically what represents the beginning and the end of each particular class interval. So once we have these boundaries at the points on your x-axis, you basically are going to use those points to gauge where you're going to put your bars. All right. So then we have to identify the highest value under your frequency column. So the reason why this is important is because you want to know how high the graph is going to go. If the graph is going to go 20 units, you want to ensure that you set up your graph to go 20 units. Does that make sense? It wouldn't make no sense to set your graph to go as high as 15 units and you have data in your frequency chart that has 20. It would not make sense. So the next thing you have to do is draw the bars, but you have to ensure that they are continuous, are touching each other. Remember, we said that the difference between a bar graph and a histogram, the visual difference between them is that you expect the histogram bars to be touching. So you guys can take this down, and then after we'll try to go through an example. We start from the table so you could see what the table looks like. How do we then take that table and break it down into an actual graph that represents a histogram? So it's going to be a chart that you're used to seeing because we would have saw it in our previous lesson. So we want to ensure that we use the same kind of material and see how we can take that material and change it into something else so you could see the connection between the two. So we saw in our first lesson how we collect data, how we can make calculations with that data, how do we group the data. Now we are looking at how do we take that group data and find a way to put a visual representation of what it is. And that's where we get our graphs that we're looking at now. Kaelon, you just reached. All right, so we're looking at this now, right? This is the table that we saw from before. So the question is, what do we need to do? What's the first thing we need to identify based on our previous notes that we just wrote? The upper and the lower class boundaries. Now, tell me, this first one here. Okay, so this here is 10 to 14. What is the lower class boundary for that? 9.5. And what is the upper boundary for that? 14.5. So now we know that 14.5 is going to be the lower boundary for 15 to 19. So what is the upper boundary for this? 19.5. Nice. And so what's the next boundary? 24.5. And then the last one is 29.5. Excellent. So these are our boundaries, which will end up going on what axis? The x-axis. Okay, that will be going on x-axis. So let's try to put it here so we could see what we would look like. All right. So we have our, let's see, we had our x-axis and our y-axis. So we starting off with the x-axis. So the first boundary was what? 9.5. Okay. So let's bring this over here so we could see. All right. So y'all can remember now. So our first boundary was 9.5. Our second boundary was what? 14.5. And we try to do this with even spread because they have the same class width. Okay, they have the same class width. What do I mean by that? The distance between 9.5 and 14.5 is 5. Distance between here is 5 and so forth. All right. So 19.5, then we have 24.5, then we have 29.5. So I'm going to say that this is in minutes. All right. So my time here is in minutes. So we did our first step, which talked about upper class and lower class boundaries and actually putting them on the x-axis. All right. So what's the next step? It says that we have to do what next? What's important next?
Identify the highest value under your frequency column to help you scale your y-axis.
Excellent. So the highest value that we have in our frequency column is what? 8. Right. Now we call this class interval because it has the highest one. What do we usually call this as a result? Remember that fancy term? The mean? Nope. Try again. Try again. Modal. The modal class. That's what you're talking about right here. So this is the modal class. So the modal class in this case is 20 to 24, and the highest it goes up to is 8. So I need to make sure when I'm doing this y-axis, I have to cover 8 at least. Okay. So if I'm going up here now, and I have my 3, 4, 5, 6, 7, 8. Even if I go to 9, at least I covered 8, right? Now, this here represents our frequency. Now, what is the next step? What's the next step? This could have been the students, number of students, frequency. I'll put number of students as well, right? We draw the bars. Now we need to make sure that they are doing what? Continuous. So if you look at this here comes the 2. Okay, so I draw that one. The 14.5 to 19.5, which would represent this one here, would go as high as what? 5. Nice. So see how I try to make them connect? I know I look a little crooked because I'm using a ruler. But you see the concept. We hit the 5 now. Now my next set of boundaries touching from where? 19.5 to 24.5 for this here. So that's going to go where? How high that one going? 8. So I need to ensure I go straight up to 8. So sometimes what I do is I just continue from this line since it's already there and go up to that 8. Come across. We could do better than that. So go up, come across. We got that. Okay. So then the last one now, 24.5 to 29.5, that goes to 3. So then I know here now is where my histogram ends. Does that make sense? Was that difficult or did you guys follow it? All right, nice. So I want you to take this down so you can have as an example, and then after we try the next one as well too. So we just follow the steps. It wasn't nothing hard, right? Very straightforward. And this now gives us a visual representation of what this table looks like. So you could just look at it, and one time, immediately your eyes gravitate towards this. Because, oh, this is the highest. Oh, this here is the lowest. So Clayton, you follow it, right? Yeah. Arvin, you think you could do one on your own? Yeah. We gonna see. We gonna see. Kaylin, you think you got it? Nice. Nice. What were you, Justin? You got it, Justin? Ladies, are you catching it? The corner, Tasia? Nice, nice. All right, everybody got it now? All right. So essentially, that's what we would have, just like this. Yeah. Okay, so I like to visualize it like this, right? So I basically tilt the table that we had on the side. You remember that table we had? Just imagine tilting on the side and just drawing the bars, right? So literally that what it looks like in that sense, you know? So you see how the boundaries come 9.5 matches with this, 14.5 matches with this, 19.5 match with this, 24.5 match with this. It kind of gives you an idea of how it's to be drawn. That's why I like to put these here, like 9.5, 14.5, 19.5, and so forth. So when I come to match it here, I know that 9.5 and 14.5 is going to have this coverage for the frequency of 2. And then 14.5 to 19.5 is going to have the coverage for 5 and so forth. Does that make sense? That's just my little trick to remember it. Okay. All right. So, you guys think you could try this, or you want us to go through it together first? You want to try it on your own? All right. Let's go. Try it. And then after we go through it together. So you know everybody gonna make sure look for them boundaries first. The boundaries, most important thing. So you guys would see the connection between what we used to do last class in terms of identifying the features and how we actually taking those features now and putting it into something. Say again. You could go up in threes, yeah, because I didn't tell you specifically what scale to use. You know, and we're just doing it now for concept to make sure y'all understand the concept. After you do it too, you could send a picture to me if you want as well. You're missing a box. You know why? Yeah, so that why you need another boundary. Which boundary you need? No, because we ain't got no data going that far. I'll even you think it out. So look at the last one. What did we use? No, not that one. The question before. That was the last one. So what was the first one?
9.5
No, where did we get at 9.5?
from that the the highest upper boundary,
The lower boundary.
the lower boundary.
Of which one? The first one?
I think so. I can't remember.
Yeah. So the lower boundary, right?
Yeah.
We need a lower boundary for this one as well too.
Oh,
No. Once you put in that boundary, that's a missing boundary that you need.
so I gotta put on 80
What's the first class interval?
50 to 59.
So what is the lower boundary?
49.5.
Alright. Do you have that on your paper?
No.
Uh-huh. Now you see why you end up in a problem, right?
Yeah.
Yeah. And that's a common mistake, okay? That has happened sometimes. So you gotta be careful with that.
Oh.
So you see that how we learn. We gotta make mistakes sometimes to learn, you know?
Yeah. I wonder who the other one was.
Yeah, exactly. That exactly what happened to you. So what has happened is that'll put you in a position now where you draw the whole graph and you're like, but wait, what going on here? Something look off, and you're trying to bust your brain try to figure out what it is. But you just remembering that first spot to make sure you get that first lower boundary. So that's why it says not just the upper boundary, but also the lower boundaries in that particular case. And you're gonna see that later on when we're doing the cumulative frequency chart as well. It's very important in that one as well too.
Okay, no problem.
Yeah, man, good shot. Once everybody feel like, okay, I try it, we gotta go through it, so y'all could see it thoroughly and see how I think through it again. The fact that you try it now gives you that opportunity to be like, okay, this is why I get, this is why I don't get. Then when you see me do it now, it's gonna reinforce that for you. So make sure you take it down and write down everything that we're doing. Anybody else get through? I'm still pushing on it. Yeah, man, these ones looking good. Seeing some nice ones so far. All right, we ready now? All right, so we set the boundaries. Important thing we learned there that we have to look at all the boundaries, even from the first one. So that's for 9.5. Okay, and then 59.5, 69.5, 79.5, 89.5. So the boundaries for 50 to 59 would be 49.5 and 59.5. So then now, when we sketching, so it's supposed to look something like this. So we got our 49.5 here, 59.5, 69.5, and so forth. And as you can see here, the bars are touching each other. Not only are they touching each other, you can see the frequency covers our highest value. So we have up to 10, and we have a little space just in case, just to make it look neat. All right, we have our axes labeled, very important for us to have this as well. Okay, does it make sense? Y'all think you got it?
Yes.
Lovely. All right. So frequency polygons. We're gonna talk about frequency polygons now, and then you're gonna see the difference between this and the histogram. So they kind of are similar things, but they are slightly different. And I'm gonna try to do one on top of the other so you could kind of see what it is. All right. So the first thing you need to do is identify the class midpoint. So that's another class feature that we spoke about. So for each class interval, you need to find the midpoint this time. And then we're going to use the lower class limits of each interval as a major point on your x-axis. So we could use those as our points, or we could use other numbers. We just need to make sure that when we actually writing or drawing the graph, the points land on the midpoint. So whatever we use on our x-axis, we just need to ensure that that number covers the midpoint of our data. So again, we have to do the same process. Look for our highest value. Make sure that we got enough coverage on the y-axis. And then we're going to use the midpoint and these corresponding frequency column values that we have to determine the coordinates or the points that we're going to use to connect the frequency polygon. So the frequency polygon is going to look something similar to a line graph, but it's going to be connecting from the midpoints. So once we're done with that, we're going to connect the dots. And we don't do this freehand. We use a ruler to do this one. So, like, if you're doing it properly for exam, that's what you want to do. You want to use it freehand. Now, when it comes to the next one that we got to learn, which is cumulative frequency chart, those ones in particular, we do them freehand. But when it comes to the frequency polygon, we do that using a ruler to connect the dots. So let you guys take this down, and then we'll go through an example of one using the data that we used previously. All right, so everybody got this now, right?
Yeah.
Okay, good. So this is what we're gonna do, right? So we have this. The first thing they tell us we need to do is ensure that we get the midpoint because it's plotted on midpoints. So 10 to 14. What is the midpoint of 10 to 14? 12, you sure?
Yeah.
Good. All right, somebody else. What's the one for 15 to 19?
17.
You sure? Say that quick. You say that quick. You sure you're right?
Yeah.
All right, nice. Somebody else. 20 to 24.
22.
22. And the last one? Anybody? The last one got us struggling?
27.
27. Nice. So that's the midpoints. So those midpoints are very important because that's what we have to plot it on. Not the boundaries, but the midpoints. So if you look at this sample here, you would see that it's going to be on the particular midpoint. Okay, so I'm going to use this and try to draw it for you so you could actually see what it is. Okay, so as I take my time to draw this, it's going to give you a better idea of how it's done in real time. Okay, so you see what it's supposed to look like, and we're going to try to do one now. But what I like to do is I like to draw it using our boundaries just to keep the same practice and habit flowing, right? Now the reason why I use those now, we can get the midpoints from them. So we know that this one starts off at 9.5, and then we had here 14.5 and so forth. So even though we say that we like to plot it on the limits, it's also cool when we do it on the boundaries. It's very useful as well because I know the center of this is going to be dead on as well too with the particular boundaries and midpoint. So the next thing I need to do, go as high as 8. So I need to make sure I could cover 8. Notice now I'm not doing anything different to what we did on the other chart. It's literally like the same thing we're doing. So we want to keep it on the same kind of principle so we don't have to think hard. Okay, we just repeating our process. Okay, so we know on this side what's going to go on this side. Frequency. Right, Clayton? Okay, make sure we stay on top of that. So this one here is going to be time. I'm going to call this minutes because we did minutes the last time with the same chart. So notice that this chart is the same thing that we did for the histograms. Okay, guys? It's the same thing. But we are going to see the difference now between the histogram and the frequency polygon. So now with the frequency polygon, I need to know my midpoints. So we said the midpoints for 10 to 14 is 12. Let me use something that we're going to see on this. So 12. This one here was 17. This one here was 22. And this one here was 27. So then now when I look at this, right, the middle of the boundary is going to be somewhere here. All right, so I know that somewhere in this center here between the boundary is where I'm going to find 12. Okay, that's going to give me that point. The middle right here is 12. So 12 matches with 2. So I know when I get ready to do that, I'm going to match with 2. So then my midpoint between 14.5 and 19.5 is what? What's the midpoint between 14.5 and 19.5? 17. Lovely. So remember, we're using these numbers because it's easier for us to just remember the concept of using the boundaries. So when we come here now, we have 23, right? Did I say it right? 20. Ah, 22. Lovely. Y'all following, y'all following. So then this here is 27. Nice. So I have my points established. So I'm having this here kind of like ghost points, just so I could have an idea as to where I'm supposed to be. So I know dead center of my boundaries, I will find my midpoint. It only makes sense. A midpoint is always the middle of two boundaries, right? So then now, my 12 matches with 2. So I could put a dot here. Some people like to put an X, but you could put a dot. For 17, what does 17 match with? Exactly. So 17 matches with 5. And then 22 matches with 8. So I go straight up to 8 with that one. And then 27 goes up to 3. Good. So what I'm going to do here now is I'm going to connect the dots, right? So since I don't have a ruler, I'm going to use some lines. So I'm connecting from here to here. And then I'll connect from here to here. Then I'll connect from here to here. Okay, so notice how this goes. We have our lines connecting the dots which fall on our midpoints. Okay, so it falls on our midpoints and then we just connect them. But remember, on the x-axis, very important, although we say we could use the limits, the boundaries are a good one to use, right? They're straightforward. They're just like what we use for the histograms, and when we use the cumulative frequencies, we have to use that again too. So it's always good to use those to help us get to what we have to do. So I want you guys to take this down, and then after we're gonna try one again. I'm gonna show you all in a deep, see how y'all handle it, and then we go through it together. But based on what you guys did, y'all doing good so far. Okay, so this one now. Let's see how y'all gonna do this one. So you have to sketch the frequency polygon. So this is the same chart that you sketch the histogram for. Now you have to do the frequency polygon. All right, so remember the skill that we used just now. We said we try to keep things the same, so we try to use the boundaries to help us, and then we find our midpoints. All right, so let's see what y'all come up with. We're using the same principles, we just need to know when to use what. Histograms we plot on boundaries. Frequency polygons we plot on midpoints. As soon as you finish, just send me a picture of it. Let's see what you're looking like, and I give you all your comments as well too. How y'all getting through with the sketch? I see so. I see so. I see so. I there watching it. I say he had it, you know. But he just took it out. Cause you had second guessed it, but you was right. You was initially right.
Okay.
Yeah, you did it good, man. Alvin, send me yours, huh? All right, so let's go through this, right? So this is how we get a midpoint. We use one of these concepts. We gotta get the midpoint either how. So we could either add the boundaries and divide them by 2. You get 54.5. We're gonna add the limits, divide them by 2. We're still gonna get 54.5. Okay. So once we got the midpoints, then we could use those points to try and plot this. But as I said, it's always nicer to use the boundaries here. So like 49.5, 59.5, 69.5, and so forth to help you with sketching that. It just gives it that ease of knowing that once you have those boundaries, the midpoint is going to be in the center of these boundaries. All right. So that's how y'all did. Y'all did well on it. You know, just remember that the midpoint, even if it's a decimal, it's fine. Okay. In this case, it is a decimal, and that question was intentional, just to see how y'all would respond to it. And y'all did good. So y'all know what's going on. That's good. Okay. So we're gonna do this here just to get a rough idea of how everything is, and I'll explain to you how we do this here at the bottom. And then once we're done with that, we're gonna go through the cumulative frequency chart. So this here is just to summarize everything that we've done so far as it relates to this, and I'll explain this here as to how we go about doing that. All right. So guys, try to do from A to B. In fact, I could probably even show you how we do the scaling one time. So the graph paper for the exam looks like this. Okay, and this is exactly how it looks. So what happens is in the exam, right? When you get a graph paper, this box here, so from here to here represents 1 centimeter. Does that make sense? So I even do like a zoom in. So if you're looking at this, right? Technically from here to here on this graph represents 1 centimeter. Also from here to here is 1 centimeter. So if I tell you 2 centimeters, I'm talking about from here to here. That's 2 centimeters. All right. So y'all understand how this box works, right? Okay, good. Now, what this scale is telling me is if I have to draw something on the x-axis using a scale of 1 centimeter on the x-axis to represent 5 meters, that's telling me that from this point here to this point is 1 centimeter, yes, but represents 5 meters. So what does that mean? So that means if I have 20 to 29, first I have to find my lower boundary. What would be my lower boundary for this? 19.5. So what that's saying is when I'm here, 19.5, okay, I'm saying from here to here represents how much meters? So this is 5. So then now I need to get to 29.5, but how far away is 29.5 from 19.5? 10. So 2 boxes would represent that 5 centimeters. So here now would be 29.5. So I know that from here to here represents 1 centimeter or 5 meters, and here now from here to here represents another 5 meters, which is 1 centimeter. Okay, so based on that scale here, we're saying that x has to represent 5 meters and a scale of 1 centimeter. So every box represents 5 meters. Now for the y-axis, what does it say? 1 centimeter represents the y-axis, which is 1 student. Okay, so 1 centimeter represents 1 student. We should highlight it. Now, what do I mean by that? So if I start off here with 0 students, what should my number here be? You sure? 1. Because now we're on the y-axis, and the y-axis says every centimeter. So going up is a centimeter as well too. So from here is 0, here is 1. So from here to here is also 1 centimeter. It's a perfect square. So 1 centimeter up from this black line to that black line. Likewise, going left to right, that's also 1 centimeter. So it says 1 centimeter represents one student. So that means from 0 to 1, that's one student, which is 1 centimeter. So then here now, I would have to do 2 centimeters. Here I would have to do 3 centimeters, and so forth. So when I'm doing my scaling here now, remember when I start my scaling, you could use a ruler or whatever. For now, we could just sketch it, but when I give y'all a practice, I want y'all to actually use a ruler just to scale it out, just to get an idea what it is. If you don't have if you're unable to print this graph paper, then you use the ruler. But if you're able to print this, you can use that. If you're able to use it on your tablet, whatever the case is. So I just want you to understand the concept of the scaling. So you can use a ruler and just draw out the distances so you could know what it is. So the first one that you said is 19.5, and we know we're gonna skip 2 boxes. So come here, that's gonna be 29.5. Skip another box, 39.5, and so forth. And that's how we get that particular reading based on the scale. Then going up, we're gonna say this started off at 0, then this goes to 1, 2, 3, and so forth. All right, does that make sense? As how the scales work? Okay, good. So just try this, see what you get. For this here, we just do the regular sketching that we was doing earlier, but you could always practice this later on. But I want to make sure y'all remember what upper class limit is, a lower class boundary, class midpoint, class width, and all this kind of stuff. So get through these quickly, and then after we're gonna go on to the cumulative frequency charts. How we getting through? How we getting through? You remember how we was doing it over here? On this side here. So using the scale of 1 centimeter on the x-axis to represent 5 meters. So remember, we said that when we put the 2 5s together, we get 10, right? Because 19.5 to 29.5 is how much? 10. So here is 19.5, and we say here is going to be 29.5. When I subtract these two, I get 10, right? And remember, the unit for this is meters. So if I take a ruler between 19.5 and 29.5 would be 2 centimeters. Why is that 2 centimeters? Because each box is 1 centimeter. So here's 1 centimeter. Here's also 1 centimeter. So then now I got a full 2 boxes worth 2 centimeters. And remember, 19.5, this here is like the midpoint, right? So the midpoint of this would be what? What's the midpoint of 19.5 and 29.5? Calculate it for me. 24.5. Okay. So technically, between 19.5 to 24.5 is how much? 5 centimeters. So you see how I get, well, in this case, meters, 5 meters. So you see how I say 1 centimeter is the same as 5 meters? So it says 1 centimeter of the x-axis to represent 5 meters. And then when I come here again, it's going to be 5 meters again. That's how I get a 10. Remember the 10 here? So from here to here is 10, which is the same as 2 centimeters. Does that make sense? So when you measure between year 19.5 to year 29.5 would roughly have 2 centimeters. Okay? So that's something that y'all could try later. But for now, I just want y'all to sketch what we was doing earlier. You know? So yeah, rough idea of what it is. And then we work on that scaling. What we got for the first ones? The class interval 30 to 39. What was the upper class limit? 39. Nice. What was the lower class boundary?
29.5.
What was the class midpoint?
4.5.
Nice. What was the width?
10 meters.
10. So then this one here, I like that one. Meters, 10 meters. Use those units. Good. So what would the class interval after 60 to 69 be called?
79.
Wonderful. What would be the upper class boundary for that interval? 79.5, right?
Yeah.
And the lower class limit would be what? 70. Because remember it says we're referring to that one before that. Okay? So, for these two, I want y'all to sketch it just to show me that you roughly know how to get the histogram for this as well as the frequency polygon. Then after we're going to go on to cumulative frequency charts. Y'all doing good. So we have to calculate the cumulative frequency for each class interval first. That's what we need to do. Once we got that, we look for the upper class boundary for each class interval. Now, with this case, we're still going to use our first class boundary to help us, but we're going to see how that's going to be marked. That's going to be marked slightly different, but it's going to be important for when we're sketching, because this here is where sometimes we often make a little mistake and actually shift it different to where it was. All right. So this one is going to be something we have to pay attention to when we're doing it. So then after, the next thing we have to do is identify the highest value on the cumulative frequency column, and that's usually the last value because it's like it's accumulating. So you'll see how that looks once we get into one. And then you're just going to plot the upper boundary for its corresponding cumulative frequency. But when we're making a cutoff to connect the dots, we don't use a ruler. We use our free hand. All right. So I'll let you guys take this down, and then after we start going through it, you guys can keep working on this and what we have to do now. And then once you start practicing these stuff, it's going to help a lot. Okay. Remember, the key thing with math is practice, practice, and more practice. All right. So the cumulative frequency chart. Now, what comes to mind when you think of cumulative? Right, something like it piling up, all right? That's a way to look at it. So say, for instance, I have this here. For my first one, I'm going to say that the cumulative frequency part for this should be 2. Now, why am I saying this is 2? Because that's the only thing I have right here, okay? Now, when I do the next line, it's going to be 2 plus 5, which is equal to what? What's 2 plus 5 equal to? 7. Nice. So then the next thing you're going to have now is, what do you think is next? It's going to be the 2 plus the 5 plus the 8. And that turns to what now? 15. Okay? So then the next thing now, we do 2 plus 5 plus 8 plus, what do you think? All right. So then this adds up to 18. Good. Y'all follow that? All right. So back to our scenarios. We usually try to find what next? Boundaries. All right. So we say it looks like this. We have the 2, 7, 15, 18. Everybody understand how we got this, right? Yep. Nothing difficult so far, right? So then now, we have to figure out what the boundaries are. So what are the boundaries? What would be the lower class boundary for here? 9.5. Then we go 14.5, 19.5, 24.5, and then 29.5. So what's happening here is we are looking at our boundaries. Okay, so let's go back to our sketch now. So I'm saying that I'm looking at the boundaries. The reason I'm looking at the boundaries, what I want to see is when we reach this boundary, how much did we have? So when I look at 9.5, when we started there, so this is going to be my separate table. I want to figure out what I want to plot with. Okay, so cumulative frequency, and we have boundaries. So my first boundary that I'm looking at is 9.5. Notice how we start with all the boundaries like we did for the histograms. We start with this first one, 9.5, but up to this point, 9.5, there was actually no data. Okay, so what number you think I could put here for 9.5? Since there was no data, what do you think I would put here? 0. Excellent. Now this is the single most important thing when you're doing this, From time you're doing this part, you have to make sure you got your first boundary and make sure that goes to 0. If you miss this, you might sketch it off. So we have to ensure that we look for our boundary first. So this one here is 9.5, which is going to be 0. And then my 14.5. So this here stops at 14.5, right? So 10 to 14, I would expect this to stop at 14.5. So that 14.5 is going to match with the 2, okay? 14.5 is going to match with the 2. How do I know that's a boundary? From 10 to 14, this one jumps from 15 to 19. So the boundary has to be between these two numbers, 14 and 15. So 14.5 is going to get number 2, which represents the cumulative frequency up until that point. Now, bearing that in mind, what do you think would go for 19.5? 7. Lovely. And then what do you think would go for 24.5? 15. And then 29.5? 18. Lovely. So, why is this important? Now, this is going to be the information that I use to sketch my data. Okay? Now, boundaries is going to represent my x-axis, and the cumulative frequency is going to be my y-axis. So, we're not doing anything new compared to what we've been doing all the time. We always draw this, and then the first number here is going to be 9.5. Then here is going to be what? 14.5. And here is going to be 19.5. Here is going to be 24.5. Then we have 29.5. Now, what is the highest number? What is the highest number when we look at our cumulative frequency? 18. So we have to ensure that this goes up to 18. So we have here 0. And I'm going to go in twos just because it's going to be easier for me to get to 18. 14, 16, 18, and then 20. All right. So right here, we're going to have cumulative frequency. Okay. You could write it sideways. I just write it like this so y'all could see without bending on the side, right? And at the bottom one here, I'm going to put that this represents what? Time. So this is time, again, in minutes. All right. So let's just get this down here so we can have them close to each other. So notice what I did so far. I identified what the cumulative frequency would be, which was straightforward. Now I just try to match what goes with what. We say we start with the first boundary, 9.5, which has to go to 0 because there was nothing up until that point. When we hit 14.5, then we got 2. When we hit 19.5, we got 7, and so forth. So then now I'm going to look for 9.5. So 9.5 matches with 0. So my first point is going to be here. Then 14.5 goes to 2, which is right here. 19.5 is going to go with who? With 7. So I know 7 is going to be somewhere about here. Okay, so right here is 7. 24.5. 24.5 goes with 15. I know 15 is going to be somewhere here. That matches with the 15. And then the 29.5 matches with the 18. Okay, so when we draw in this now, we kind of draw it like a curve. So we go like this, curve it upwards, and then we curve back down like we're going down. So it's like we swooping up and then curving across like this. All right, so that's how we do the cumulative frequency. What you guys think about this? I want y'all to try this, take this down, and then I'll give y'all one to try. What you thought? Or this? Yeah, it does. All right, so take this down, because remember, this is steps I need y'all to follow. So the building of the cumulative frequency chart, and after you build that, you come here and figure out what you're plotting. This here is a crucial step right here. This right here is a crucial step, okay? And we could use this information to find the median, which I will show y'all, and that would be it for what we're doing for today. But then next class, we're gonna have to learn how to do the quartiles, upper quartile, lower quartile, which is stuff that you guys gonna have to learn about. We call them measures of dispersion. So you're gonna learn how to use this chart in particular to do a bit of prediction, interpretation, and so forth. Take this down, then after I'll give you all one to try, and then after we go through it together. All right, you guys got it down? Okay, nice. All right, we got it now. Nice. All right, so we see here we get this important chart. Don't forget this chart, guys. Very important. So then once we got that, we able to plot the cumulative frequency. All right, so I want y'all to try it for this one. So we have to start from scratch where you find the cumulative frequency. After that, we're going to find the boundaries. And after we find the boundaries, we're going to do the corresponding values for the cumulative frequency and try to sketch what that cumulative frequency would look like. When you finish doing this part, send me a picture. And then when you plot the boundary, when you do the table for the boundaries, send that to me as well. And then you can start the graph. I have to see just to make sure that you do it right before you start drawing the graph. Y'all got this, man. I know y'all got this. So what we got to learn from this too is how to do the median. And then once we learn how to do the median, y'all would basically have a rough idea as to what you could do with this cumulative frequency. And then after that, y'all gonna practice some stuff for me during the week. And then we'll learn how to do it with quartiles and all that kind of stuff. All right, so let's have a look at what this should look like. So it's gonna be this, and then after, once we do our boundaries, we know that for the 9.5 is gonna go to 0. 59.5 is going to go to 6, 69.5 is 16, and so forth. And then we take these points and we're going to plot them on the graph. So this is what it's going to look like. Okay. So once we got that, we know what's happening. All right. Okay. So when we want to find the median on the cumulative frequency chart, we have to draw a horizontal line from the median of the frequency on the y-axis to the cumulative frequency curve. Okay, so where the horizontal line meets or intersects with the graph, we then draw that vertical line to touch the x-axis. So we're going to use our same charts that we just drew to be able to determine the median using that information. So I'll let you guys write that down, and then after I'll show you all how we do it. So when we're looking at the cumulative frequency, right, we know that this value goes up to 18 for this particular chart. Okay, so this was a chart that we did earlier. We know it goes up to 18. So this is 15, 16, 17, 18. All right, so 18 is the total that we have in terms of people in that particular study. Now the thing is, what is the middle of 18? What number is the middle of 18? Because remember, the median is where we find the middle. Can someone tell me what is the middle of 18? 9, correct. So we look for 9 here. So we have 5, 6, 7, 8, 9. Fellas, y'all following, right? Y'all seeing what you're doing, right? So 5, 6, 7, 8, 9. So we start from 9 and draw a horizontal line. So this horizontal line comes from 9 because that represents the middle of 0 to 18 in this case, because 18 is our max that we had. So we draw the 9 across and then we draw a line down. Remember, I hit the curve and I came down. Now when I'm looking at my space in here, I know that each of these here represents 1, 2, 3, 4, 5. So I know from 19.5 it goes to 20.5, 21.5, 22.5, 23.5, 24.5. So then I know my median is 20.5, and that's basically how we find a median using this particular chart. Now if you do this, because you guys probably didn't have yours spaced evenly or whatever the case is, because we're just sketching it, yours might be close to 20.5 but not exactly 20.5, but it's close enough to show that that's how the concept is. So what I want y'all to do is for the first graph that y'all sketch for me, so not the one that we just drew, so not this one, the one before that, which had the first boundary as 9.5. I want y'all to sketch this part, show this part, so you could mentally see what it's like to get the median. So once you got that, you know the median is 20.5, and then I'll show you all how to do it with the next one. You do it with the next one that you did already, and then that's basically how we do the median component of this. So try that. See if y'all get it drawn, then send it to me, and make sure it comes from the 9. All right, y'all got it? Y'all get a median drawn? Yeah. All right. Okay, so try it for this one as well too. So this one went as high as, well, how high did this one go? What was the highest value? So this was a cumulative frequency that we did earlier. Got it, right? Yep. So therefore, what number should we be drawing from on the y-axis come across? 15. So we go 10, 11, 12, 13, 14, 15. So we come across by 15, and then we go down. All right, so we go down. So I know that this is 59.5, then 60.5, 61.5, 62, 63, 64, 65, 66, 67, 68.5. So my median is 68.5. All right. So take this down. This is basically the last part that you all had to do today. I'll send you all some stuff to practice this, and then after, we'll see how you guys do. So you guys should be able to do well in this. Y'all got the general concept. So I'll just send you some stuff to basically practice what you did so far as well as this. Okay? So just to give y'all a little extra practice on putting everything together. If you got any questions, let me know. Everybody understand everything? Yes. Nice, lovely.